Hi, in this video, we are going to do a nice theoretical calculus problem. So let's get started. This is the question. Let a continuous function f of x satisfy the equation, and this is given as integral of 0 to 2 f of x times 6x minus f of x dx is equal to 24. Now, based on this information that a continuous function satisfies this equation, we have to select the correct options. The options are 0 to 2 f of x dx is equal to 6, 0 to 2 f of x dx is equal to 24. Then we have f of 2 is equal to 12. And D option is f of 2 is equal to 6. Now, this kind of problem might seem difficult because we don't even know what f of x is. We just know that it is continuous. So what information can I figure out from this equation? So technically, when you do an integral from 0 to 2 or 0 to any constant of some function g of x dx, what you are getting is the area under the curve here, right? So the area under the gx curve from 0 to 2 should be the answer for this integral. So technically what we have here is the area under the curve f of x into 6x minus f of x is 24 when measured from 0 to 2, right? So how can we use that fact somehow, right? So let's rewrite this integral like this. 6x f of x minus f of x whole square dx is equal to 24. This is what we have, right? Now you should see from here that it would be very easy to make this into a perfect square, right? Because there is f of x square already present. That this is going to be the middle term. So our first term should be the square of 3x because this is 2 times 3x times f of x, right? So first term should be square of 3x. So what I will do is I will add a 9x square and subtract a 9x square. Why am I adding and subtracting it? Because it doesn't change the overall integral. And then write the other two terms plus 6x f of x minus f of x squared, right? This thing evaluated from 0 to 2 is equal to 24 apparently, right? Why is this step going to be important for us? Because if you complete the square, you will be able to get a square type of term, and I will tell you why that becomes important. So here you get 0 to 2, 9x square minus, you should have 3x minus f of x whole square, and the whole thing dx is equal to 24. This is my equation after a little bit of simplification. So splitting this integral, you get 0 to 2 9x square dx minus 0 to 2 3x minus f of x whole square dx is equal to 24, right? Now let's calculate this because this is pretty easy. So this will be 9 into x cube by 3 evaluated from 0 to 2. So that is 3x cube from 0 to 2. And that turns out to be 24, right? So you are getting 24 minus integral 0 to 2 3x minus f of x whole square dx is equal to 24, which implies that integral 0 to 2 3x minus f of x whole square dx is equal to 0. So this is the conclusion that I am getting. Now think about it. How is the area under a function going to be 0? The only way the area under the graph of a function, and you can see here, this part of the function is a perfect square. So it is always positive. So the area should have come out as positive, right? If the area is coming out to be 0 for a function that is always positive, the only way that can happen is if the function is 0, right? The only way this thing can happen, the area under the curve is 0, is if 3x minus f of x itself is 0. Because if it was not 0, this would always be a positive quantity and the integral can then never be 0, right? So that gives us this statement that 3x minus f of x is 0 and f of x is equal to 3x. And now the question is done because we can find simply f of 2 is 6, and we can also find the area under the f of x graph from 0 to 2. 0 to 2, 3x dx will be 3 by 2 x square evaluated from 0 to 2. So 3 by 2 into 4. So this will be 6. So our options are A and D. The area from 0 to 2 f of x dx is 6 and f of 2 value is also 6, right? The correct options for this become A and D. And that solves this question. So I hope you understand how something which was completely unknown, the function was totally unknown to us. But by doing a simple manipulation, completing the square, we were able to write that expression as 9x squared minus 3x minus f of x whole square. And because the integral of 9x squared was 24, that gave us the information that area under the curve 3x minus f of x whole square from 0 to 2 is 0, which means that 3x minus f of x must be 0, which basically gives us the function f of x, right? That finishes off this problem. I'll see you next time. If you like the videos, please subscribe to the channel and share it with your friends. All of these problem solving and revision videos will be useful for you for JEE Mains and Advanced. I'm trying to do at least a couple of problems every day. So if you do it diligently every day, a lot of your syllabus will be revised by the time the exam comes. So please go through this problem solving strategies playlist. It is definitely going to help your preparation. Okay, that's it for now. I'll see you next time.